I can't get the YouTube thing up, and I'm seeing I'm streaming, but it won't show me the actual YouTube link for it. I'm not gonna mess with that right this second.
That's fine. Not
Okay, guys, I'm looking at the time right now, and we're at the top of the mark here. I am gonna try to make sure that mine does not make it when people. Also gonna make sure that it doesn't put people on microphone when they join, so too many interruptions. Keep in mind that we have a chat going, and that you can always ask questions that way if you don't want to interrupt, or feel very free to interrupt if you have questions. I have quite a lot of material to go through. Typically, this is not something that really is done over a single meeting. Huge topic. So what I'm going to try to do here is an introduction, and I'm going to skip a lot of things that I don't think is relevant to the group. But if you feel like there's something missing, let me know. Yes. I'm quiet. I've never been known to be quiet, man. It's better. Yeah. Actually, let me fix this, because I actually added a filter yesterday onto this, and remove that. Now, is this better?
It's filtering you out.
Now, I removed the filter. Is it any better?
Yeah, when you raise your voice, it is.
What about now?
Pretty good.
Okay. So let me know if I'm not talking loud enough. I will definitely raise my voice if it's not loud enough. But I removed the sound filter just in case there was a lot of noise in the background here when I hit the keys. But anyway, that should be working.
Away from the mic.
I'm not actually. I'm pretty close to the mic, but that's part of the problem, part of the challenge here. So anyway, I'm gonna get started. And please, as I said, if you have questions, or particularly if you can't hear me, let me know. Feel free to stop me and all that stuff. So as we talked about last month, we talked about containers, and I promised that we would do a follow-up. This was actually the topic that was requested. But in order to us to really understand what it is we're going to look at in today, not in an hour, but sometime today, we sort of have to remember what the containers were all about, right? So what we're going to talk about today is what's called the container platform, and in particular the Openshift container platform from Red Hat. I am going to use a lot of official slides that we use to talk to Red Hat customers about what this is all about. I do have some customizations for this, but this is pretty much straight out of any public deck you can find on both upstream, downstream of what Openshift is about. So nothing here is secret and all that stuff, and it is extremely high level. And I'm gonna warn that I am not planning to go into very much details about how things works underneath the covers. We can do that if there's interest, but I didn't really want to bore people, and it also takes forever to go through all of that. So, as I said, we started last month talking about containers. And just to recapture what containers are, right? So to me, a container is a very effective way to distribute software. It can do a lot more than that, but that seems to be now really the de facto way of why people are migrating to it, because you can run any code by using a single command, and it will download and run everything in isolation and include everything you need. You don't need to make sure you resolve dependencies. You have no problems with conflict between dependencies between what you already have, maybe in another container or on your system. It's all a self-contained, hence the word, way of looking at how how an application is deployed. Not only that, but that container by default has very limited access to your box. So it's not like your risk, even if you don't know the software, you are not necessarily risking as much as if you ran it directly on your box either. With all of that said, I also need to point out that a container is really nothing magic. It is just a Linux process. The magic happens in how the kernel is being told to treat that process and what security it adds around that process, and all that stuff. But it's not, hey, here's something that has never worked before. Everything running inside the container is just like you have always seen it running on Linux. There's nothing new underneath the sun. What containers really do is they add at least 3 other layers of security that you're not used to seeing. But if you're using systemd, you're actually using this, but you just don't know. So SE/Linux, C groups, and namespaces are all things that are heavily related to how the Linux kernel, at least on, well, SE/Linux has alternatives, but it is basically an extension of the security part of the kernel. And C groups and namespaces are kernel features. And these things have been in Linux for a long, long time. But it wasn't really until we saw containers come around that they started really coming to their own. And people and the community started using them for groups. I mean, I remember C groups before containers. And everyone was going, why would I want to do that? And now it makes a lot of sense. So very briefly, I'm not really going to go in detail, but SE/Linux is like a traffic cop. It tells you what you're allowed to do or what a process is allowed to do. And that is not just about what files it can access. It is also accessing system resources, or it could be anything from networking to a device on your system. C groups is about managing resource distribution. So it's a way of telling the system out of this many CPU resources, this much network, and so on. Here's the slice that you get of that, which means that you can, if you have a 16-core box and you're running 100 processes, you can make sure that one of those processes don't take 15 of those 16 cores to themselves. You can limit how much each of these processes actually sees out of the total, particularly when everyone wants to get access to the process at the same time. Typically, if there's no one using it, who cares? But if everyone wants to use it, we want to be sure everyone gets a fair chance. That's what C groups is about. And namespaces is basically letting the kernel control, well, the space of names, but I mean, basically the names you see of everything, from what devices exist to what networking exists to what file systems you have access to. And basically, when you tell the system what is available, namespaces control what you see. And by default, you have access to everything in the system. That's the default namespace. But with containers, that's not the case. So one of the things, and I showed that last month, that happens is that the PIDs, the process IDs of everything you're running, gets mapped to another logical space. So the container basically looks like, hey, I'm the only one in the world, and I have PID 1, which is typically the boot, meaning like system, the init process of the OS. With a container, that is the process I'm running in the container. It thinks it's PID 1, even though it is not. That's what namespaces can do. It can cheat. So it can map the real world into a logical world, and it can filter out from that logical world what you should not be seeing. So with all that cool stuff we looked at, and because the containers can do so much, why do we need a container platform? Why do we need to make it more complicated? And there's a lot of answers to that. We have seen Kubernetes basically eat the world here, and there's a good reason for that. And that's simply because at scale, we don't run anything on one box. I mean, if that one box breaks down, we don't want to lose all our IT, right? We spread our stuff over multiple systems for redundancy perspective, but also because if I'm running 1,000 applications, that won't fit on a single server anyway. So I need to have something that allows me to spread my workloads over multiple systems. And I need to be able to either share and manage all the resources across those boxes. Doing that without a platform around you is a lot of work. And it is not easy to maintain. And you require a lot of resources for you. And you may not even be able to do it unless you have access to advanced technology to get it done. So for instance, if you have two containers running on 2 different hosts, how do you network them, but make sure that that network is only accessible to those 2 containers so that it's not shared between others? And that's a very typical use case that we see on a container platform. So beyond the single point of failure, we also need to be sure that what happens if there is a failure. So software errors happens all the time. We have memory leaks. We have bugs that makes a program break for some reason or another. And one of the things a container platform can do is to ensure it knows how to react if things break. So when a failure happens, it can automatically, without any operator involvement, restart workloads. If a node goes down, it can automatically restart all the stuff that was running on that node somewhere else. So it does a lot of automation because as a state machine, which is basically what Kubernetes is, it knows what the desired state of everything should be. And if it's not like that, it takes action without being told to do so. And on top of that, you also need to be sure you know how do you add storage, how do you add, and I said network isolation, how do you control how much memory should be available to deployment, and a ton of other stuff. All of that is what the platform provides on top of the container. But in the end, it's still a container underneath. And we're going to definitely be seeing that today. Another thing that has really made Kubernetes, I guess, everyone's darling, is because it is so fit for automation. So it makes making automatic deployments, it makes making automatic a reaction to, hey, build codes, so you have a new version of a piece of code or you need to do a new test. It can help automate all of that stuff. So from a developer perspective, you can make it so automated, all the developer does is commit to Git and everything else happens automatically from then on. And that is really something that Kubernetes helped make much easier. Now, there was tools before this that could do it, but it was very easy to make them break the second time around. But Kubernetes, because everything is ephemeral, we know it runs the same way every time. So just a warning, I'm going to talk about Openshift, which is, of course, the Red Hat product name. That does not mean there's no upstream. There is absolutely an active upstream called Okd. The Okd project is, if you go to the site that I have on this slide here, it actually shows how to create a cluster locally on your own box. And it is literally that simple, as you can see that command. Now, it does require resources. It cannot run on a little laptop with 4 gigs of memory. Don't even try it. It will not be a happy day for you. That said, it can run on a fairly beefy laptop fairly easily, and you won't have access to everything in what is in Openshift, but you will have an environment that can run and manage containers for you. And that's really all most people from a developer perspective need. So Okd definitely is something you can look at as I want to kick the tires, or hey, I want to actually look at some of the features that are in here. How can I either use that on my own, make my own fork of it, or something else? That's what that project is for. So everything in Openshift, like everything Red Hat, is open source. The difference between Okd and Openshift is that Openshift goes through a lot more testing, basically. And upstream is upstream for a reason. It means that Okd most times are not full, but it has features that have not yet made it into Openshift. And they may make using it a little harder to begin with, unless you know where to do. Can anyone use Openshift? Sure. It is actually free for everyone for up to 60 days. So if you go to the cloud.redhat.com, you have to have that account that I put on the mailing list. Anyone can get one. It does not cost anything, and you go on the cloud and create a cluster, and it will tell you here's the software you need to download, like the installer, and you go and pick your own poison. So you can tell, I want to install in AWS, or I want to install it on Google Cloud, or you want to install on your own hardware, and it will basically take you through the guide of how to get that done. And it will be free for 60 days. It is, all the containers that you're going to run are all publicly accessible. There's nothing that requires special access. The only reason you need to sign in is because accessing Red Hat code requires, for legal reasons, an acceptance of terms and conditions that says what you can do with that code. And that's it. So let's take a look at what OpenShift actually looks like, again, from a very, very high level. So OpenShift's ideal, and this slide is actually pretty old. This has pretty much been the same slide that has been presented ever since we did OpenShift the first time. And we're talking 8 years ago. So it's been focused on self-service, and self-service is from a developer perspective. If you've ever worked in an organization where you consume IT resources, and for instance, you're being told that you need to use your expertise, or your group needs to use your expertise to create some kind of application that helps the organization out. Getting access to resources can usually be a red tape nightmare. I've had I've had stories from everything between 6 to 18 months wait from the time a group decides that they need these resources and request them till they get them. That's not very effective. And the next problem really is that everything is very, I'm going to use the word fragmented. And there's been lots of reasons for that. We might have had a network person, and we might have had a DNS person. We may have had a security person, and we might have someone for Linux. And underneath them, there might have been other things to deal with web servers and all that stuff. And they all had to do their own little task. All of that took time. And often that would also be manual. So you may not even get, I've seen where they provision 10 different hosts because you need that for your project, but they're not provisioned the exact same way because it wasn't done automated. So the idea here is self-service, that we don't need that workflow. We can, as a developer, do a single click or command and deploy everything needed without asking permission. That goes from networking resources to storage to, and you can, as a developer, a lead developer, decide who has access to my project. What part of the network can communicate to me. You can set up your SSL. You can set up everything on your own. There's nothing in here that tells it you have to wait on somewhere else to do stuff to get resources running. Now, there may be a process you have to follow eventually. Everyone has a pipeline, but that pipeline is typically defined also by the developers. So we avoid that long list. And again, the idea is that there is no wait to get out and running. All the other things are sort of dependent on that. So we have multilingual with automation with collaboration. If it runs on Linux, it runs on OpenShift, or rather, it runs on a Linux container. And multi-tenant simply means that it's a platform that can be created to serve multiple very different projects that should have no access to one another, including even being able to say, here's production and here's development, and they can run in the same cluster and still be fully isolated and have no access to one another. We can have different groups of people that have access to some projects but not other projects. We have all kinds of ways of slicing and dicing who has access. There's a ton more features, but this, to me, some of the highlights of why the OpenShift platform was initially created, and it tries to solve these kind of problems. So OpenShift is a Kubernetes platform. This talk was, I labeled this the Enterprise Kubernetes Platform. Now, there's tons of options today that didn't used to be, but there are tons of options today about what a Kubernetes platform looks like. The base version of Kubernetes really doesn't have a lot of automation in it. It knows how to do runtimes of containers, and the rest is really up to what you choose to plug in on top of that. So with OpenShift, a ton of features are added that are not in Kubernetes that augments it. And that goes from anything from monitoring, logging, how routes are being done. We can do service mesh. We can do middleware. We can do CI/CD and build tools and so on and so forth. So it takes Kubernetes, all the cool stuff of Kubernetes, and adds additional features to that just makes it much, much simpler to use in the end, in particular both from an installation but also and maintenance perspective, but also from the end user perspective, the developer's perspective. So from an architectural perspective, this can get a little bit tricky. Now, if you see, there's a couple of color differences here. So all the blue stuff is Kubernetes, and all the green stuff is Openshift. Does Kubernetes work without all the green stuff? Absolutely. But you won't have some of the features that Openshift provides. That's the difference, right? So within Openshift, we talk about compute, network, and storage as major areas that we deal with. Compute is the host, the CPU, memory, and all that stuff. Network is how things internet connect, and storage is where we do persistent storage. So from a Kubernetes perspective, we add a registry, and we add logging and metrics across the whole cluster. Much easier to deal with. We have a good deal of automation because everything is operator based now that tries to tune the system live as it goes. And that's also something that is not in Kubernetes, how the nodes themselves are being managed. We provide alerts, Grafana, all kinds of other dashboards around all this stuff that you don't find in Kubernetes. But again, Kubernetes runs fine. I can take any Kubernetes command that exists for another vendor and run it. No problem. So here's the scary picture. The reason I have this is that I keep hearing that people want to do, we can build our own Kubernetes because Kubernetes is, fairly simple when you look at the project. I mean, it's not huge. Openshift is a pretty darn big product. And then you start from, we can build it our own. Well, this is the container native foundation, or cloud native foundation, that it basically governs the standards around, Kubernetes basically. And these are all the projects that they now have under their roof. And most of these projects, in one way or another, can be found in Openshift. That's what you have to manage and understand yourself, how all of this needs to work. How do you optimize them? These are the technology stacks that really are required as either understand them so you can make the right choices, or you need to basically make a good long mix between them. So the trick here really is that when you are deciding that, hey, we need to make this cool new app that's going to sell millions and millions of dollars of products, is this where you need to focus on, or is it the app that needs to be focused on? And from pretty much every perspective that I can think of, it should be the app that you need to be focusing on. The rest, if you can get that as a service or someone else providing, that will be a benefit. Because there's no one that can really take, so Red Hat has hundreds of people dealing with us on a technical level from engineering that understands some of these products, and they all try to work together. And then we add on top of that a huge partner ecosystem around it where everyone can come together and say, here, we provide this feature, and now everyone can easily consume that feature and add it to Openshift if they need to. So I will show you that a little bit later about what the operator hub looks like and where all those features can be found. But what I'm trying to say here is Kubernetes is complex by itself, but it's nothing compared to all you need to deal with all the building and all the security and all the scalability things you have in normal architecture. And that's what this is trying to show. So let's look at some of the core concept of Kubernetes. Right? So this is going to be a little bit fast. So a container is what we learned about last time. It's sort of like the smallest compute unit, right? We can't run anything unless it comes inside of a container. And that's going to be very important to think about as we continue here. We cannot run a command unless it's in a container. Any command. Nothing this system does will not run as a container. One of the funny things for me has always been to look at Openshift as a container running containers. Openshift itself are nothing but containers. Even the operating system underneath it, the Core OS, the RHEL Core OS operating system, is basically a container-based OS on a box. So it is a container running containers that manages containers. Everything is a container. Once you get over that shift in your mind that you just need to basically deploy a container with your code in it, it is not that hard to do. But it's not a yum command or an apt command in order to get software running. And that is a little bit tricky to begin with. So containers comes from a binary. We covered all of that last time. So we have a container image that we pull down and then we run it. We can have multiple runtimes on the same binary. Each runtime is ephemeral by itself. It has its own copy and write file system on top of it. All of these images are located in an image registry. Consider that, again, like the yum or apt repository for all your RPMs or dep packages. It's just for containers instead, and there are hundreds or thousands of those. You can create your own. You can use external ones. Docker Hub is probably the most well-known of these, but there are lots of alternatives out there. And you may need to use more than one. When you're inside the registry, everything has a name. It also has what we call a tag or version number, or however you want to use. The tag is just a text. It doesn't have to be a number. But it's a way of having multiple versions or instances of the same piece of code, allowing your users to determine which version or what features it is that I need to get a hold of. Within the actual registry, there are different groups or organizations that you can have access to or not access to. So just because it's in a registry doesn't necessarily mean you have access to everything. Now, containers are in Kubernetes are not the lowest unit. Well, it is what it executes, but we cannot operate on a container directly in Kubernetes. It has to be done to a pod. And a pod is sort of like the wraparound that controls how that containers inside the pod reacts. And this simple picture tries to illustrate that a pod is one or more containers. There has to be one, otherwise nothing would make sense. But you actually have lots of use cases these days where you have more than one container for a pod. But they, as you can see here, they share everything, including their IP address. So two containers running in the same pod can't listen to the same port on the network. That would be impossible because they would be fighting for the same resource. Another cool thing is that once you're in the same pod, you now have full access to each other's memory space and all kinds of other funky stuff. So you can do caching servers, what we call sidecar technology that actually inspects traffic coming in and figures out what to do. They have a very close relationship once they're inside the same pod. And that has a lot of advantages and features later on on some advanced stuff. For the stuff we're going to look at today, one container, one pod. And it's going to be very simple that way, and we're going to keep it simple today. Once we have a pod, we use something called a replication controller or replica set to specify, here's an image, and I need that running in X number of instances. So remember, I said earlier that Kubernetes is a stateful or state machine. So it keeps a state. It remembers the state that you tell it to, and then it just executes on that state. And the replica set is a state control. So it basically says to Kubernetes, this image has to be running in X number of instances, and here are the rules about how it needs to be run. And that could be anything from it's only allowed to run over here, it needs to be running under these with this storage, under these security rights, blah, 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 blah. All of that will be in that replica set. But it also means that when I am dealing with Kubernetes, in order for me to have, let's say I'm running out of, I'm having too many requests coming in, I need more resource, I need to add a new server. I just scale, I add another replica to my replica set, and it adds a new pod. Or if I have too many, I can remove them. So a deployment definition or deployment configuration. So a deployment configuration is a OpenShift terminology, and deployment is a Kubernetes terminology, and they are almost 100% the same, but they're not yet. So OpenShift started with the whole idea of deployment, deployment configuration, when Kubernetes had no idea what that was. A deployment configuration is an easier way to define all the rules about your deployment that is persistent throughout the whole life cycle of that deployment that you have. So in there, you define what it is you want, and it will actually create the replica set for you and manage that. So all your action goes to your deployment configuration or deployment, and it will tell the system what to do. We have another way of doing this. So often if we have to, let's say we need to do a database. And one of the things that we need to get that database to do is to be high available, meaning it needs storage on multiple systems. So if one server goes down or one pod goes down, it doesn't lose all the data, and hence your users get mad at you. So instead of using a replica set, we can use a daemon set. And that ensures that one instance runs on every node, or how many nodes we ask it to be on. And we can now attach separate versions of storage and everything else. So they're still treated as one, but I don't need to treat it as something where the storage and memory and all that stuff are different per runtime. Again, this is mainly used for something that deals with state. And when you need to deal with persistent storage, but it can be used for other things. So while it looks like a replica set, a daemon set, it's definitely something used today by a lot of features. Another feature that you will see is something called config map. So remember last month we talked about containers being ephemeral. Ephemeral simply means that it doesn't store any data. Right? At the moment it stops running and you start it again, it starts from point 0 and forgets everything that happened since last time it ran. So in order for us to store configuration data, in this case, that is sort of like static data for an application, and that could be anything from how many threads do you need, or what type of configuration do we want the server to be in. Most stuff has a configuration file, at least one, when you set up your code. And that is done by a config map. And once you have a config map, you can expose that to your pod in lots of different ways, from simple environment variables to a file on the file system, and a few other ways of doing it. But in general, those are the two ways that is mostly done with a configuration map. And that allows the pod to see that data, and so because it's separate, when you have a new version of your container, your configuration stays put. It does not risk getting changed. Another feature is, because you can have multiple namespaces here, I can have the same configuration map for production and development, I mean the same name of it, but they have different content. So when I deploy my pod in the different namespace, even though it's the same physical ID, the same image on the disk that runs, they can have different configuration depending on what context I'm in. Finally, we have another way of dealing with data that deals with stuff that we don't really want to have available in clear text, and we call those secrets. So this is data that typically would be something like system passwords or private keys, things that we really don't want to be exposed. So what that happens is that it gets encrypted by default, and it also restricts who has access to actually see these secrets. So by default, it's only the owner of the project that can actually see these, and no one else. So even if you're the developer, you can tell it to use it, but that's it. You can't see what's inside of it. But it works the same way as the config map, because I can now have a different set of passwords for my development and another one for my production, but the same container. And that's pretty darn powerful, if you ask me. So once we run a pod, this is where things get, I think the first time people see this, get a little on the complex side. So no one can actually see the container inside the platform. By default, Kubernetes has two networks running. It has a pod network and it has a service network. The pod network is really just there for the container system to work. It gives every pod a unique ID, so it can be found on the resource, but it's not routable. Meaning, well, sorry, it can get out, but no one can get into it. There's no access to it. And even worse, because pods come and go, like there's no tomorrow, the IP addresses and names of them keeps changing, so no one can really use that as anything reliable. So we have something called a service instead. And a way of looking at a service is sort of like a DNS and a load balancer on steroids. So a service creates a name, which is literally a DNS name internally. So the service name can be used as the host name, let's say for a database or for a web server, to represent a set of pods behind it. And the service ensures that if that number of pods changes, to link the new ones automatically to that service. So as a user of a service, I don't need to know how many pods, what they're called, what they do, that is underneath it. And that's also very powerful. So every access point that we have to actually see from a network perspective what a pod does is usually to a service. And why there are small exceptions to that, and that's really a little bit beyond what we're going to be talking about here. So as I said, what the pods do when they talk, so in this case we have a front end that needs to talk to the back end, and it goes to the service to talk to it. And that's the way it works. Now, from the outside world, we need a URL. We need access to the cluster. And if I'm not in the cluster, I can't see any of the internal networks for good reasons, right? So we have something called a route, or what Kubernetes now calls ingress. Again, something they stole from Openshift and made their own. They're getting there. It took them a while. So a route is basically a way of taking a service or a particular instance of a service and expose that with a URL. And what then happens is there's a reverse proxy called either a router or an ingress router, depending on what system you're using, that runs on Openshift, that listens to certain external ports. And then you have a load balancer that hits that on the outside so they can get in. But it basically helps translate this URL that you see here into an access point into Openshift. And Openshift then sees this host name and knows what service is behind it and sends it to the pods. So from an end user perspective, I just go to this URL and I'm accessing what's inside Openshift. And you don't see the complex set of routing that is there. Now, if you've ever set up an F5 yourself or another load balancer, what I just said sounds very familiar what you already have been doing. Particularly if you're dealing with SSL search and you need to deal with CNI and all kinds of inspection, this is what's happening already. And a lot of those features are built into routes too, so you can add certificates and all kinds of other stuff to it. But in its bare concept, it's basically just is a external link to a service. Another feature that is important when we runtime is not just do we have configuration data that is static, but we also have the need to have dynamic data, and databases are a very typical example, but you may also have runtimes that deals with other data sets. And you need persistent. I mean, in the end, that's what computers do, right? We process data, we get input data that came from some state, and then we process it and puts in another state. And we want to remember that state. Otherwise, what's the whole point? That's what persistent volumes are about. And so because the pods are all ephemeral, they don't store anything, we need to tell them how to get storage. And we use something called persistent volumes and persistent volume claims to do that. And what the very short version of what that story is all about is that as an end user, you tell it how much storage, and end user meaning being a developer, I need, let's say, 2 gigs of memory or 2 gigs of disk space. It will create a persistent volume for that. And when it runs, that volume gets attached to your pod and gets mounted inside in your container automatically for you. So when you write to a certain point, to a certain mount point inside your container, you're literally writing to a persistent volume that does not go away. And when your pod moves around from another machine to another and all that stuff, that persistent volume moves with it. That's very important to think of. Another component that also is dealt with by the deployment configuration is how do you determine if things are actually working? This is pretty much a lot more complex than most people think about, because it's not a matter of whether the process is running all the time. You may have a web server that seems where the process for Apache is running, but it's not responding correctly. Something else is wrong. And we have liveness and readiness probes so we can set up URLs or some other means to verify that a pod is actually ready to receive data or to do its thing. So we have a readiness test that says, are you up and running and can you start, or are you alive and still responding? And you can define what those are. Those are not the same for every program out there. So it's a matter of, is it a URL you want to probe, or does it need to run a certain command inside the pod to verify that it runs, whatever you want it to be. And based on the data on this, Openshift can then take action and say, well, if you're dead, I'm going to kill whatever is running and start a new one, or whatever else you've set it up to do. I already covered the storage claim, but this is another way of looking at it. One of the things that I want to point out here is that when I say physical volumes, it does not really define a particular type of storage. It's all abstracted away. So regardless of what, depending on what environment you're in, you may have a different type of storage available to you. And the cool thing is, as a developer, as a user, and when I say user Openshift, it's usually a developer. I don't need to know how NFS works. I don't need to know how NetApp works, or how VMware works, or Amazon, or anything else. I just say I need storage, and I tell it where to put it, and I'm done. I don't need to install drivers or services and set up my mount points in FS tab or anything at all. I just use my storage regardless of where it's coming from. And if you ask me, that's probably half the battle won already, because that has typically been where the problem has been, that the guys, girls, whatever, that manages the storage, they're very smart in storage, but most other people don't know as much as they do about how to do that effectively. That can now be automated to something called a storage class. So we still need these smart people to manage the storage class and tell it what to do and what's available, what options to set up. But once it's set up, everyone can do an easy storage allocation and use it. And that's pretty darn powerful. The last part here of all these overview slides is I'm going to talk about projects or namespaces. Both those two are almost the same thing. Namespaces is the term that Kubernetes use. Project is the term Openshift uses. In the end, they almost do the same, although the project has a few more features in it to help with some definitions. But in the end, it helps isolate everything. So when you create anything in Openshift, anything in Kubernetes, you have to have a namespace. So that's usually the first command you do when you start up, is to create one, if you don't have one. And within that, whatever you put in there is not accessible to people who does not have access to that namespace. So this is a way of implementing multi-tenancy, not currency. So allows me to say one set of users have access to development, but maybe you don't want those developers access to production. Or maybe you have people accessing development needs to have read-only access to production. Or there can be all kinds of different ways you want to slice and dice that. And that's what we use the projects for, is to basically hold who can do what, when, and why. So that was all the concepts that we have. So how does it all come together? So within Openshift, one of the things that it does that most other vendors really don't care about. So if you go to Amazon and do EKS, it only runs on Amazon. Right? If you want to move to another cloud provider, you're going to more or less start, I wouldn't say start all over, but there's a lot of changes you need to do. With Openshift, we don't care. It runs the same way regardless of what platform you're implementing in. So what compute network you want, the compute system you want, what network infrastructure you're using, what storage infrastructure you're using, it is all up to, oops, the wrong button there, all up to the end user to use, right? So we have a concept of a worker node. And a worker node is where all the end user workloads end up. And you can have, and you should have more than one, but you can have any number of those. You can even have different categories of worker nodes. You could have some that are meant for production workloads, some that are meant for development, maybe some for AI ML, where you have like NVIDIA cards sitting in the box where you need to do CUDA stuff, or all kinds of ways of slicing and dicing what that workload needs to be like. And in general, as an end user, as a developer, I don't really care what those worker nodes are. I just care that there's capacity. I don't specify which one and everything else. That's simply going to be an admin task to deal with. To manage the whole cluster, we have a set of Masternodes. I'm hearing rumors that name might be changed, but basically we have a control plane. Let's call it that instead of Masternodes. And a control plane is what anytime you have a cluster, something needs to manage the life of that cluster. Is it up and running? Is there a quorum? How do we deal with rights so everyone knows what's going on? Who's, being sure that you actually schedule the task that needs to be done only once, and all of that stuff. Those are the kind of things that anything that does a cluster management deals with. So from a master perspective or control plane perspective, that's its main job, is to deal with that. Oops. That was weird. Okay. I've already done that. So I don't know why that slide was in there. That was definitely an error. So the state of everything in the master is all stored in an internal database called etcd. etcd is a project. It's been around for quite a while, and it turned out it's an object-based object store, basically. And it's pretty darn efficient to run, particularly over multiple nodes, and it's very good at dealing with what happens if things break, right? If one node goes down, how do we recover, all those kind of things. But every time you do a command that sets a state, it is stored in etcd. Now, as an end user, you have not, you will never know where an etcd is stored. You have no access to it, actually. It's locked. Only the super duper admin can see it, and we typically only query it if there's a system problem. And even that, it's rare, but it does happen. So on top of etcd, we have quite a few basic Kubernetes services. So in order to talk to Kubernetes, let's call it that for now, we need to have an API server. Basically, we need to be able to send commands, so it needs to have an endpoint where we can send commands to. That's called the API server. And the Kubernetes service needs to be able to figure out how to run stuff. That's called the scheduler. And that basically you define a set of policies that says, how do you determine where the best possible place to run something is? And you can put in rules about this project is only allowed to these areas, or these servers only should be allowed to run this kind of workload, all kinds of scheduling rules. But once they're set up as a policy, they're set, and the cluster manages themselves. And finally, there is a set of cluster management features of how do we actually change how do you talk to a node? And that's basically what the control plane does. It's once it's determined what to do, it manages all the other nodes in the system, sends them commands, do X, do Y, ask them what they're doing, and if they're responding back in a negative manner, then it will send out correcting stuff. So Openshift has almost the same set of features on top of it, right? So Openshift has this additional API server. So it does not overwrite the Kubernetes API. It is an addition to it. So there are specific OpenShift components, objects that only exist in OpenShift. And those are handled by the OpenShift API server. Now, when you send a command with kubectl or with OC is a command line, you don't care which one of those are responding. The system knows how to forward between them. So it's not a challenge. But just know that there's a component inside of OpenShift that adds on top of Kubernetes. And then we have something called operators. And I'm not really going to go into depth with that. But operators is a big thing in OpenShift 4. And basically automates everything that OpenShift does. In particular, when it comes to both installation and updates. Operators is what manages how do you go from one version to another, how do you implement a certain feature and all that. Instead of you writing a script to figure out how to set it all up, the operator is a already packaged solution, either from Red Hat or from one of the many hundreds of partners that are out there providing features, that tells Kubernetes, tells OpenShift, how do you run this and how do you update it. And then finally, there's a web console, which is not as part of Kubernetes. This is pretty important to think about. We're going to see a nice GUI very soon, and that's the OpenShift web console. Kubernetes doesn't have that out of the box. Now, a lot of other places, they create their own web consoles too. But just remember, when you think Kubernetes, that's not part of the core solution. And then there's a lot of things that are sort of intermixed, where OpenShift either augments or adds on to existing features of Kubernetes, or vice versa. And that's everything from monitoring, logging, software-defined networking, and all kinds of other stuff. So OpenShift makes some choices of what SDN, for instance, to implement out of the box. And Kubernetes may have other options, but they're not being tested by the OpenShift teams. So, I mean, it's a very flexible architecture. It's very important to understand that up front that you have so many choices that you have to limit yourself very consciously what you do. So all of this stuff here, so notice that there's a little bit of a division here. Some things runs on the control plane, something runs on the worker nodes. And in general, they're all the same. A control plane node or master node is the exact same thing as a worker, except depending on what task they get. So in this case here, we can have all our monitoring and logging across multiple systems. We also have something called a registry. So remember, we said all the container images, they come from a registry. OpenShift comes with its own internal registry that is integrated. So when you build containers in OpenShift, and we're actually going to be doing that today, they get all stored in the internal registry. You don't need to bring your own stuff with you. And that allows you to consume your built containers. Otherwise, you couldn't pull them. That doesn't mean you can't have an external registry. That's important. This is not replacing if you already had a registry somewhere with all the stuff that you've done that you want to expose to a full organization or just your home network. This is an addition to that. We have our alert manager putting in here. We have our Kibana Elasticsearch, which is what we can use for dealing with performance data. So we can do graphs, dashboards, all kinds of funny stuff that is kind of cool to look at. And of course, we have the OpenShift router, which is in Kubernetes term called Ingress. So it should actually be blue. I think I need to change that on this slide here. And all of this stuff, plus all the stuff you're adding, is all accessible from the outside through a command line or to the web console that I talked about earlier. And now we're looking at this, and I actually added this morning after thinking that, hey, something here was missing. If you have never seen this before, I need to explain a couple of things. So, and now we're looking at the whole shebang here. So once I have things running, I'm going to try to show that in here, is my masters run these specific services here, but each node then has all my pods running. And notice that in this case here, this picture is trying to use the image as the application. So we have many, many instances of the same applications running. And they may be running on multiple nodes, and there may be more than one running on the same node. And just in general distributed out. But one of the things that's important to note here is that these individual pods don't care and don't know where they're running. So if they want to talk to one of their pals, one of their, they want to communicate something to one of the other instances, they don't have to know what node they're on. It's very important to note that all they do is to use the pod IP address. And the infrastructure, the container platform network layer then figures out where's that running and sends it to that machine where that is actually running. So one of the things that is then happening because of that is because I can do all these different loads, it also allows me to deal with what happens when things fail. Right. So in this case here, if a pod fails, we call it auto healing. It basically tells the state machine that I'm not at the state anymore that I'm supposed to be. So if one goes down, then and I need 5, then so I only have 4 left. It just starts a new one, and then maybe on the same box that it starts up on, if it can, it may be on a different one. And at that point, it doesn't really matter. It depends on why it failed. It could be that node ran out of resources or someone disconnected from the network. Who knows? Something weird can happen. But it automatically does that with no one reacting. Actually, I often find myself having to inspect logs, and I have to go pretty deep until I realize that actually has happened, because I really didn't see it happen when it happened. It also deals with what happens when a node goes down. So everything running on a node is going to be marked as failed when the node no longer responds, and then it acts the same way. It then starts rescheduling all those workloads onto the other boxes. This is only possible to a container platform. And this is where things get from the very complex way if you do it manually without a container platform to you didn't even touch it, you didn't even know it happened anymore. This is pretty darn big. I've talked to people that basically goes, man, holy crap, that's like a week's worth of work for us in just that one response. And that's just one of many, many features. Very rough. I'm going to talk a little bit about when you install OpenShift, because if you ever want to do this yourself, you're gonna hear two terms. You're gonna hear something called IPI, and you're gonna hear something called UPI. And the difference, and then of course we have a hosted option too. The latter one is really for organizations and IT departments where you say, well, I don't really want to run this stuff. We want to use it, but we don't want to be the admins of it. And hence, you can go, Red Hat announced a week ago something called ROSA, which is a managed OpenShift on Amazon. We have Arrow on Azure. And it basically allows you to run a single command or do a single request, and it sets up a whole cluster that that platform manages for you. And all you need to do is use it. But when it comes to you installing it on your own, you have two options basically. You can basically use a fully automated install. It's called what we call IPI, Installer Provision Infrastructure. And what this basically does, it takes everything you have and from scratch and builds up a complete cluster from nothing. So you can point it to Amazon, you can point it to Google, or even to a VMware environment, and it builds up everything needed, including your load balancers, to set up the whole server from scratch, with very basic questions being answered by you, like what is your domain name, where's the DNS located, and stuff like that. So it knows where the environment is, but that's it. The pre-existing infrastructure, UPI, is where you go and say, well, I don't really want you to manage every component of it. I have some requirements because I have this network. It has to be on there. It has to look like this. So you start doing some customization, and that's where things get really funky, because now you need to answer a lot of questions for it to come in correctly. But once it's done, it will work fine. Particularly in high security environments, this is something you do all the time. So this easy install button is just not available in those environments, but there can be very good reasons why we need to do that. So I had quite a few more slides, but I didn't want to do those. I wanted to be sure that we actually got plenty of time to actually use OpenShift and ask questions. So I'm going to stop here for if there are any questions of what I said while I set up to actually go to our slide here to show my screen so I can actually do the demo with you all live. So any questions? You guys are so quiet. Remember to unmute yourself if you want to say something. Okay, so let me do this. Switcheroo, and there we go. So I'm going to stay on this side for now. You guys are more than welcome to actually follow along. If you go to learn.openshift.com, and let me just remove this introduction first so we can start from scratch. This is the site that you're going to get. And actually, I thought I fixed that. Hold on a second. Oh, there we go. You should switch to this guy. Ah, there I am. And then I made this little guy down here. Or maybe I didn't. Oh, there we go. Ah, look at that. It worked. Hope you can read it. I didn't want it to be very blocking, so I made it yellow with some black one around it, so you should be able. But learn.openshift.com is basically where everything is going to happen from. And what we're going to do is follow 2 of these training courses. And as you can see, this site comes with a bunch of them. Some of them are a little aged, but if you've never seen OpenShift before, don't consider that aged. This is actually pretty leading edge stuff if you are just getting into containers. So we're going to start with the Using OpenShift course first, right? And that gets us to this page here. And we're going to do logging into an OpenShift cluster. This takes us to some very basic components of how do we actually interact with it. And this is really where I love Katacoda, which this is based on. It just makes everything so simple that everyone can do this. And it comes with a little guide, and it is very, very simple to do. So you log in here, and you hit Start Scenario. And if you have never been here before, or the system sort of didn't realize you were going to log in, it may take not even half a minute, maybe 10 seconds to establish a complete environment for you. This is a very temporary environment. If you don't use it for a little while, it is going to get killed. And that's simply because it's free resources, and they all cost money because they all run in Amazon somewhere. So anyway, so this talks about we want to basically create a console, right? So we have 2 sites here. We have a guide, and if you notice to the guide, we can't see that on this page here, but as you go on, you can actually just double click or click on a link, and it will actually fire the command over here. Here is the terminal, meaning here is the command line version of OpenShift, and we will look at that. But we also have a console. And when I click on that, let me click that one out. It should come up and say, here's the login. Right? So this is exactly that little demo system that I'm running on now. So the first thing it says, well, to log in, we need to go log in as developer. So we log in as the developer, and the very secret part. Yes?
We in the audience are just seeing the slide that says demo time.
Yes, you are. Wow. Let me fix that. You should see my video right now. Do you do that?
Yeah, we can see it now.
Okay. Sorry, very much. Thank you very much for telling me that. So let me go back here. Right, so everyone should go to learn.openshift.com. And actually, let me stop this, and I know I'm going to leave the page. This is weird. Don't know what that is all about. Okay. But you guys can see it because my secondary monitor does not show the blue jeans at all. So you can see the interactive learning portal right now. I did not hear what was said there, but as long as everyone can see my screen that says interactive learning portal, we're fine.
We can see it.
Okay, good. Right. So I go to this learn OpenShift or using OpenShift, and I start with the first one called logging into an OpenShift cluster. And as I said, as you can actually see in the background, it's a little fuzzy, and that's because it's starting the environment. Because I left it and told it I was leaving. But so basically, what we're going to do is we're going to look at a very basic example of getting access to OpenShift. So this is the screen we get to initially. It tells us we have a terminal, we have a guide here, and we have this console that opens up OpenShift in a browser. And it wants us to log on as the user developer. Password is developer. And once we log in, we are there. This is the developer view of OpenShift. You may be prompted for a tour if you don't have the right cookies. That tells it that you've already seen that. So if you say it comes up and asks you, do you want to go to the tours? Just say no. It's not needed for this. But this is a view of OpenShift. Now, that's one way of logging in. Right? But okay, so we logged on. It wants us to do one thing before we move on, and that's create a project. Remember, everything we have to do is to a project. Oh, it already did that for me. That's interesting. Interesting. So anyway, so it wants us to create a project. To create a project, we click up here on the top on projects and say create project. Once we do that, it wants us to create a project called my project, and you just type my project. Now I already have one, so that you shouldn't be needing to do that. But all you need to do is do that, and you get to this screen. Because there's nothing in here, it basically expects us to create something. And that's true, and we will get to that in a moment. So we go in here and says we created a project, we have it ready, and if I go in now and say look at all my projects here. Okay. That won't work because I only have one, that's right. I can't see all my projects because I only have one. If I have more than one, I would see a list here of all my projects, but that's fine. So we go down here and say we're fine. Go on. So I gotta warn a little bit. There is a little bit of an inconsistency because between versions of OpenShift, some of these UIs change slightly because we get feedback and people say this doesn't make any sense, and they change spelling errors or change the word, but these guides don't necessarily keep up with that. Anyway, so we go in here and we say, well, now we've done everything on the console, but how do we do that on the command line? So with OpenShift, to write a command, we use the OC command. So this is one of the things I love about Katacoda, right? So I can just click on the command line and it just repeats it for me. I don't have to type it myself. I'm that lazy and I like this. And in this case here, I can write the same commands that I did before and it will log me in. Now, the difference here is that I need to know what that server is called. And that's what they coded in for us. So now, because this environment has been set up for this particular server, it knows about it. But if you're doing this on your own for the very, very first time, you have to specify the server address in there. But so now that we are in, we have a set of commands that might be good to know just to be able to look around. So the who am I is a good old-fashioned Linux command. We have that in OpenShift too, so it's logged on as developer. Now if I do here, I'm root. Although I'm not really root in the sense of being access to mess with things. But anyway, just notice that these two are not the same and they have nothing to do with one another. You can also say, where do we log on? You could see that up here already. It is actually listed here, but that's another way of being told where you are. And we can also say what projects. Well, this is actually fun. So I don't believe it actually opened up the right demo for me. Okay, so let me actually do one thing here that you guys shouldn't be doing. I'm going to go one step backwards and figure out why it did not go to this URL. It still didn't do it. This is odd. Okay. There's my project. Wow. Okay, well, that made no sense. It may be because I've done this several times to test it and it cached it. I've never really had this problem before, but anyway. So now when I say get projects because I created it, I see it. Is everyone with me so far? You should be able to click exactly the same thing and also get your My Project back automatically. There's a couple of descriptions here of what's really going on, how it figures out who you are. There are maybe times where, particularly now that we have, well, this has changed a little bit. It may go in when you log in and say that you actually have to create a token and take you there. It is basically just click on that link, and once you log in on the graphical terminal, you get a token, and it's very, very simple to use. So,
If I could ask a question.
absolutely.
Is it possible to make the text bigger at all? We can obviously see like topic 3 and everything, but as far as what's in the terminal.
Let me try. Does this help?
Yeah, helps me a little. I'm not sure for everybody else, but yeah. that helps.
Perfect. Okay. So one of the things we now want to do is to say, okay, we logged on as ourselves, but how do we actually log in and deal with other users and get access? So if I log on as something called user 1, so this is another way of logging in. As you can see, you can actually specify username and password instead of being prompted. But notice that when I log on as that, I'm told that I have no projects. Right? It tells me, hey, no projects, no, can't find anything. So, well, let's create a new project here. Right, so it goes under, yeah. So we go back up here, and we can say we want to go into edit project. And where do we want to do that? Yep, okay. Back to our project list. And we can say edit projects up here. And we go on the role bindings. So role binding is a fancy way of dealing with security. We're absolutely not going to touch everything it can do, but it's called role binding for a reason. It's not called access rights and so on. But it is fairly very easy to do. Right? So I can't remember whether it actually doesn't say grant user 1. I say user 1 read only. Right, and I can say what kind of access do I want. I want to give him view, and the viewer, the user is user 1. So I want to grant that user access. I've now granted that user access to my project, and if I take my console and I say good projects now I'm seeing it. Now I can't change anything in the project, but I can view the content in there. And that's simply by just granting access. So you could have a user group that, of all the people that are working on a given project that needs to have access. But you also may need to be able to say that certain users their role are testers, or maybe they're documenters, and some are developers, and maybe there's some database admins. They all have different things they need to do. And you can break down for each of those groups of these ideas of what kind of access they need to have to the system, to your project. So as the project owner, meaning the one who created the project, or get the rule of admin for that project, you can determine who has access and who can do what, like this. Very simple. So all this telling about is what I just did. It just, go and create all this stuff. And now we can create our own little project here as this new user 1. And what this is going to do is to actually say that I want to give the user developer view rights to this project, but I want to do it from the command line. So this is the command line to do that. So basically, again, it says add a role to a user. The role is view, the user is developer, and that N stands for namespace. And it said, we created a new namespace or project, same thing. In this case, and that's what we want to get access to. So that's the command line to do what I just did the other way around in the browser. So if I go up here again and I hit show my my projects, I can see my mesh sequence here showing up. Everyone with me so far? Let me actually zoom in here too, because this is kind of small. Okay. So switching back and forth, because we already authenticated, so everything is done by tokens here. I can actually switch without being asked for my password again. As long as that token is still valid, that's all I need to do to switch between one user and another user. If you really want to be a little more tricky about how this is being managed by the Kubernetes API, these commands can help you get insight into the information it has stored in it. There's a .kube directory. Let me show you. Oops. So inside the .kube directory, there's a config file. And that's a kind of a big file, but not in this case because this is a temporary system. But typically we don't really go in and edit it, but it does tell you what this particular user have had access to. And here are the tokens that are available to it throughout this the lab. So that's the basics of getting access. But one of the things I want to show here too is you don't just have to stick around and do the commands that this guide shows, right? So I can say get, this is going to be rejected, right? Let me see if I can do this. Well, won't work. What else can we do? So, okay, secrets, for instance, right? Yep. Let me try to do my secrets. So here's a list of the secrets that gets generated automatically when you create a new project. Not going in details with that, but I just want to show you that I can take a lot of commands that are there. Right? So another thing we might want to say, so we've done the OC command. If you are very new to Openshift, OC has its own help. So by just typing OC, it gives you a very brief overview of how to get started. And you can say OC, I think it's called commands in the old days. Nope. OC help, there we go. And it gets you an overview of some of the most commonly used commands that Openshift supports. We've already done the login, we've done the project, we haven't done the status, but as you can see, there's quite a few things, and as I said, this is just the beginning. There's a ton of extensions running in Openshift that has their own commands on top of it, so you might even have special database commands and other things going on in here. In logout, we've done the who am I things, but one of the things we didn't do was status, right? So I could say OC status. So to me, I've always used status to just verify that when I'm logged in and where I'm at, meaning what project am I in? So I'm in my projects and this is the server I'm on. And if things are running, it might give me a little bit more status on that. But again, so OC command is the most primary. Now you can do the same thing with okay. Yeah, well. That's part of the problem with Kubernetes, right? So in Kubernetes, namespaces are a admin or a piece of information, so you can't necessarily list it as an end user. Now you can be granted access to do that, but anyway, kubectl allows me to do anything that I can do from Kubernetes, and that doesn't necessarily mean it knows how the Openshift extensions work. But if you're coming from pure Kubernetes from somewhere else, all of that stuff will still work. Let's do another demo here. I want to actually do a demo that allows us to do something fun with some applications. So we have one here. When we go back under introduction, it will say getting started for developers. Now notice there are tons of developer stuff, and there's even some in here that are based on admins, but most of this stuff you're going to find is for developers, because those are the people who actually want to use Openshift, mainly. Those are the end users that we set up. So in this little developer, we're actually going to create one applications, but we're going to use two different containers to do that. And one of the things I'm going to do after this call is to file a couple of bugzillas on this, because this is a very old demo and it says Openshift 3 in it. Just ignore that. But for now, just keep it at that. I this is the one that is available for the public. So I want to be sure we all use the one that is available. So again, just as like before, when you go in here, it starts an environment. I can close this browser up. And I have access to the terminal and a console. And again, I can do the login. And I can do the who am I. Right, so I'm all there. So now we want to go to the web console, and that's this little link here. And it will probably want us to log in again. Yep. Okay, so we now logged on. I'm just going to skip because we already did this. And we're going to create our project again. I am pretty sure I have a cookie problem somewhere. Oh, there we go. There's the tour. Go away. Don't want the tour. Okay. So now I'm going in here, and this is the way it should look on your screen. There should be no projects. And I'm going to make it my project. Again, go back to our guide. So we have that. And just to make sure everyone understands. Do notice here, remember when we did that first test, I don't know if you noticed there were fewer options on this create screen than we have now. And this is something the admin determines. What do you have access to? What is even installed? What is optional and what's not optional in your system? So this is not a screen that is static in that sense. It very much depends on the installation that has been done. Anyway, so we go in here, and then we're going to switch to the developer view. Oh, well, sorry. So one thing we didn't look at before. So this is the developer view, and it looks very basic, and it is supposed to be basic. Now there's a ton of options that we can add to this long list as we get more advanced deployments, but we're not going to look at that like pipelining. But we also have a view up here called administrator. That gives us a little more insight into what the system is. Now I'm not a system administrator, so I am limited in what I can see and what I can do. But I do have access in here to things that typically would not be available to a developer. I mean, I can look at my deployments, my configuration, my stateful sets, my secrets, my jobs. All this stuff is not really directly accessible, at least not easily to the developer. Now, they can indirectly, once it's used, or they get to an object that can use them, they can see it, but not before. We can look at networking, our services and routes, and we're going to get into this in a moment. We can look at how the storage, create our claims, ask for storage, and so on. All that stuff is available from in here too. For our perspective, we're actually going to be using both of them in this little demo here. So first thing we do is go to continue, and basically what we want to do is to take an existing container image and deploy it. And so they have written up here a very old, and I mean really old, image of something I've actually done too, but gone on and actually, go to a hotel room and you get 100 people joining, and everyone sits and do what you guys are doing now on the phone, or on this video call. So we had what we called it a road show, and so this is basically a container image that was built for that. So we want to deploy that, and the way we do that is we go on so this screen here, we can click on add. We get the same screen as I just see here, right? So if I say I want to add an image, and up here on the image name, I'm gonna type that name that I got from the guide. And the way to do that, you just click on this little guy and it copies to the clipboard, and that way it's easy to copy and paste. Once I do that, it verifies it. It says validated. If it doesn't say validated, you didn't copy and paste it right. This is technically all we need to do, but I want to do two things first. I want to first click deployment config, and I want to remove the route. This guide actually shows how to create a route manually, so it will take it out. So typically you would say always expose it. In this case here we say no, and I want to use the deployment config because I want to show features that are not yet implemented by the Kubernetes community, that are all in the old deployment configuration. Other than that, that's all I'm doing. I could have kept everything default and it will still work. Right. So I say that and I say create. Once I create, I get a screen here that looks kind of odd if you've never been in the OpenShift developer screen before. And while it works, notice that it makes this circle in here. This is actually our pod running, and this circle that you have, this color, indicate the state, and now it's running. So within less than 10 seconds, it went from working on it, and it's now fully deployed and running. And I will go into details with that. Now, if you don't like this weird way of looking at the world, click on this guy up here, and it shows you a list, a traditional list without all this colorization and all that. But in general, you can do the same thing. I like this graph though. Particularly once you start having a lot of objects, it will have lines between them and all kinds of other things that helps you understand what's going on. So what we have here is an application. Applications is kind of like a logical concept to OpenShift and Kubernetes in terminal, because an application is just multiple deployments all working together. And we have a deployment configuration. So if I click on that, I get a screen here on this side. I'm going to ignore the health checks for now. We're not going to care about it. So what this tells me is that I have a deployment configuration that has one pod running. Notice the name of the pod looks kind of odd. Right? The name of the container image that I deployed is called podsmap catacoder. And then it has a 1, and it has all this weird data after it. And that's part of that uniqueness and ephemeral that we have. We're going to look at in a moment of how to deal with some of it. I can also go in and I can say, view the logs, that what is this container doing? So this is sort of like logging on with SSH to actually see what stuff is doing. This is where all the data that particular application is sending out will end up for me to look at. As you can see, this is my pod view. I can look at what is consuming, memory, CPU, networking, all that cool stuff. I can, because I'm in a pod, I can see what container image is running. It tells me that image that I indicated earlier. It also tells me it's using a secret. And this is because most pods needs to be able to ask, like, what's my IP address and stuff. And they do that of Kubernetes. So in order for them to do that, they need access to a service account that has access to the API. And that's what this happens. So by default, that is going to happen. You can remove it if you don't want to or give it more rights. But again, I didn't have to specify it. It knew that that's the default of applications. And then I have a little bit of a log that tells me, what did I do? If I really want to play with OpenShift on Kubernetes, everything is in YAML. The raw YAML for what I just showed you is in here. This is not something where you start. But this is literally the document. When you go to the Kubernetes documentation, this is the stuff that they're talking about. They will tell you what all of these options are, what you can do, what you can't, what options do you need, can you do, and all that. And notice how much this automation made for us out of the box. Didn't have to do diddly squat. We have environment variables. In this case here, we haven't defined any, but they're in here. And we always look at logs. We looked at the events earlier. And this is really a neat little thing. There's a command to do that, but this is the way I'm inside the container now. So again, like I showed you last month, I'm PID1 is the Python application that is now running on this thing. Now we haven't accessed the application yet. We'll get to that in a moment. So let's go back here and we will look at the deployment again. If I can figure out how to click on it with my mouse, I don't know why. So that was the pod. We looked at the log. Notice there's no build because we just ran a container. And then we have a service. And the service, remember, that's the way we access a container or a pod, right? So what this basically says is I'm going to listen on port 8080 and send it to the port on the pod on port 8080 underneath it. Now, which pod gets it, it doesn't care about. And what do I mean by which? There's only one running. Well, that's because we only have one scale. But what if I set this up to 3? I'm now creating 3 containers, all running the same applications running at the same time. And that service that you saw earlier is now going to load balance. And again, this blue thing it's going to show, well, I'm not sure why one is terminating, but I don't care right now. As you can see now, I have more than one. And again, my service is the same name. Understand or deal with, hey, which of these parts do I actually need to go to? That's what the service does. But notice that we don't have a route because we told it not to create a route, right? So in this case here, okay, so I guess I must have clicked on the down arrow without knowing it. Anyway, there we go. So now there's 3. And I can add any number of that. Now there is an easier way of doing that. You can go up here and you can say edit pod count, and I can say I want 10. Right. And now it makes 10 in implementations of them. And again, this is typically where if you are in an IT and you're running applications and you get this desperate call from your customer service internally that says, hey, our users, our customers can't access it. We're running out of, we're getting timeouts. We need more resources. That's typically a call you fear because setting up new servers can be not hours. It's a click here. It's actually less than a click. If we went all the way through and did it automated, we can actually have the system automatically do this, add more capacity, depending on what's going on. So this says 10 now. I don't know what. Oh, view all 10. Ah, there we go. So there's all the 10 we just created. And I can remove this down again. Let's just make it 2. Now, one of the things that is important to notice is when a scaling event happens, how does it determine how to do that with the application? As you can see here, it actually does it pretty easily, and that's because the application is just a simple little Python app. But if you have a database, for instance, the idea of getting a new version or anything else like that, the update strategy and the deployment, or the way you roll out things can change, and hence you may need to actually go in and see if I can figure out. Not showing that right now. Let me go this way. Nope, won't show that in here either. Anyway, I'm sorry. So you can change the strategy. There used to be a little change the strategy up here, but it's not showing up in this machine, on this version. I don't know why. But you can go to replace. And by doing a replace, what you get out of that is that instead of just adding or subtracting, it will remove everything running first and then import in an update for a database, for instance, where you can have multiple different types of data going on and you don't want them conflicting with one another. Okay, so we looked at the deployment configuration. We saw everything running, but we don't have this exposed. So we want to make sure we can actually see this application, and that's what we need that route for. So the service is only accessible for things running inside of OpenShift. It's not accessible to things outside of it. So in order to get access, we need to expose it. And we do that playing the administrator and creating what we call a route. So you can see I have no route in my project. And I think this is actually, that's step 2 or 3 or 4 here. I haven't scaled down. So this is basically dealing with step 5. Sorry, didn't update that. So we can call this map route. I don't care. I'm going to leave host name blank. You don't need to provide one. And actually, if you do, you need to be sure that it actually matches your installation. I only have one service, so I'm going to pick that. And a service can have more than one map. You may have, for some applications, there may be more than one port that it's listening to. So you have to pick which one it uses. In this case, I'm going to use the port 8080, and that's only one. And I'm going to say create. And by doing that, let me go back to the developer view. You should see a little link showing up here now with the URL in it. If I click on the actual deployment, you can see I also have the URL down here. So this is the name, the host name that it created for my application. If I click on that, it starts up, and that's what I mean by saying OpenShift 3. And right now, it doesn't look very cool because it's just a map of the US or the whole world back. And you can zoom in and out. It's a cool little app, but there's nothing going on. The last step we want to do here, if we follow the guide, is to put some data on that map. So we're going to take actual source code from a GitHub and compile that into a deployment. So I'm going to copy this link for this GitHub. Again, I'm going to go back to my screen here, and I'm hitting add. I want to add data from Git. And I'm going to put in my URL for the Git. So what it does now, it actually reaches out to that GitHub and inspects it, sees, oh, that's Python. I know Python. And then it goes in and suggests, it looks like you need to use this builder image that we have available for you. I don't even need to specify anything. I'm going to again pick the conflict. In this case here, I do not want to expose it either, and this is on purpose. But based on just giving it the Git, I get everything automatically found. It knows what I'm dealing with. It knows everything. I can just basically go straight to create. And I can do that on command line. I can say OC new app and give it a Git, and that's it. Everything else is automatic from that point. So if I click now, notice there's a little thing working, and that's simply because it's doing a compile. So if I hit click view log on this compile, we can follow along to see what it's doing. So what this actually does is goes to GitHub and it clones the Git repository and puts it into a special builder image that it's creating. And that builder image is what it just finished up creating. And then it's going to go in and run the Python make my application code that it was told to run. And that is part of what's inside that GitHub repo is how do you build this? So that's how it knows what to do. It goes out, gets the dependencies needed. Notice some of it is kind of old, so it now tells you, hey, you should probably use newer versions. Once it's done all this compile, it then creates a container image. That's what that git commit is all about. And then it pushes it to the internal registry. And it now says it's done building. Everything is hunky-dory. You see now it's blue because it's waiting to deploy it, to be running. And now it's actually complete run. So that's all I had to do is in order to build my own container from source. That was the steps. Now, there can be times where it's not as simple as this, but that is literally the bare minimal needed to set up a container to run from source. Not with me going out, figuring out who else has created it from me, but me as a developer saying, I have some Ruby code, some Python code, some Java code, or whatever language you have, and I need that running in on a container platform. That's it. You don't need to do anything else. Now go back to our little guy here. I'll hit refresh, see if it actually has done something yet. It should. Hello. Wonder when it gets the update. So this little app has a hard-coded thing in it. Not hard-coded. There's a configuration file in it that tells it what to do, and it should actually show up here in a moment. Oh, there we go. There's the parks. So it got the data, and it basically sent it to on a REST call. So now this map shows where the national parks are located in the U.S. Actually, the one around the world. So two apps working together is what this shows. So if we go back in here, so notice that they are part of the same application. And that's part of what we mean by applications in OpenShift, is that there is an interaction between two. And you can set up, there's a special visualizer, not right in this version here, but there's a visualizer that allows you to show whoever's viewing this, which apps talk to other apps and under what conditions and so on. But that's the basics of creating a full application. So we basically deployed two containers. If I go back in here to, let me do it back into this. I have two deployments. So I have one pod here and I have two pods running here. So I have three containers running to just do this application. That's about it. Now there's a lot more training classes here on the screen that you can go to, and you can go in and do all kinds of funny stuff, but it's all in the same way, right? So it is, so ODO is the OpenShift developer orchestration. So it's a much easier sim interface than OC for developers to deal with. You can play with that. And that's another thing if you don't necessarily have the URLs. So there used to be oh yeah, if you do. Wow, they have really changed this. So you can go on the command line tools if you go up to the question mark. And it should show up a little screen in a moment with some download links where you can get the command line tools that I'm talking about here. And it's taking a sweet while, but this demo was never meant to run this stuff, so it's probably not cached any of it. Anyway, it will show up eventually when it gets around to it. You can work with other things. You can deal with federated clusters. You can deal with GitOps. A lot of interesting demos, all for free. Don't need to run anything locally. So I'm going to switch back here and find my presentation again. And any questions so far? I mean, did anyone follow along, do it on your own? Or was I the only one doing this? Everyone is quiet.
But I had a question.
Sure.
From your demo and experience, just for people kind of starting out, I was wondering, you went over a lot of great concepts, so thank you for really going through the details. Just wondering, what would you say are some of the common downfalls that you see beginners get into, either conceptually or while setting things up? I'm not sure if you have a list.
There's a lot. Every piece of new technology that you get to learn, one of the things you have to do is forget what you know. And so I hinted at some of the things earlier, right, that everything is a container. So for instance, let's say something is wrong, right? You're getting to the situation where this click that I just did fails. It comes out and tells you there's an error, I couldn't deploy, or we can't run the container. And you need to figure out how to solve that problem. I cannot tell you how many times I've been asked how you SSH into OpenShift. You don't. It's actually a security feature. Most of all, you don't need to because there's a lot easier tools out there, but you're so used to being able to, hey, I have a server error, I need to log onto the server, look for the log files, look for this and that, and they're all located and being treated very, very differently. It doesn't mean that I can't do it. It just means there's a very different way of doing it. So for instance, there's a log aggregator that we typically would add as part of OpenShift. And what that means is that if I have something, again, I had like 10 instances running of that application, and something happens. If I had to figure out which server I have to go to look at the log files, but it may be depending on messages on another server and all that. It's very complex once we have more than one running. The log aggregator gives me a single point of view where I can say, this application showed me all the logs from the whole system. And now I can see exactly what happened in what timestamp and all that stuff. But it's not business as usual. And that's typically the biggest problem when you start out, that you have to forget how you used to do it. And that whole idea that, oh, I need to go on and install this piece of software, so I need to log on with SSH and do a yum install or whatever it is. All of that stuff is out the window. It does not work. It is not how this works. Make a container and then configure that container to run any way you want. That's the way to go. And that's the mindset challenge that I often see early on. These demos are created with the mindset of make it look easy. And it is easy for these fairly straightforward examples. Well, I call them straightforward because I'm used to showing them. But if you're comparing this to how you normally would do a deployment or compile or anything else for production, this is actually quite complex demos. And that whole idea of, let's say, when I showed I can click on the arrow up and add another instance. Again, I've had customers looking at each other going, you do know, they all look at, that was like 2 weeks worth of work, just adding more capacity. And it was done in And this shows in seconds, not minutes or days or anything else, in seconds. And then on top of that, we have all the automation, but it's a very different way of thinking that it's a little bit tricky to get into. And that's typical. The problem I have is that people are still thinking the way they used to and forget or need to get used to another way of basically of framing that whole discussion. So I should actually now be able, you can all see my slides again, right? Yeah, okay, good. So again, the learn@openshift.com is a great place, lots of demos. As I said, some of them seem a little ancient by now. Ancient in the sense that they're more than a year old. Sorry, that's the world I'm in. I'm gonna see if I can fix that, but they still work, and that's really the important part. If you want to play around with OpenShift yourself, meaning you don't want to use the demo system, and if we have time, I will show you my local system running that has a lot more features in it. Cloud.redhat.com is where you start. Again, you can get a free, I think, might be on the next slide, but you can get a free 60-day trial in that and play around with it. And all the documentation is on docs.openshift.com, and that is not just for OpenShift, but all the OKD stuff too. Yep, we did this. So yeah, I need to, the whole idea of this was to show that while everyone talks about Kubernetes being hard to do, I wanted to start out with as an introduction of this is how simple it can be used. It does not mean that Kubernetes is simple. I do not want to come across as this is what I'm telling you. But it can be made to serve you and not the other way around. And once it's running and once it's configured right, particularly when we start using operators to help you maintain it, it gets actually to the point where you can start focusing on what it is you're trying to solve. Now if you're as a home user and you're just running 1 or 2 containers, this is beyond overkill. That you do not need Kubernetes for that. You can take Podman and you can create a service, a systemd service out of that, and it will make sure that that 1 container that you have or 2 are always running. And I do that on some of my systems, and it works fine. There's no need to go beyond what all that stuff. But for anything where you have more than a handful of things need to be running, this starts solving problems for you. Now, again, I skipped over a lot of features. We didn't talk about custom configuration options or environment variables, how they deal with them. And if we had the time, I will have shown one of the demos where this map actually changes character based on a parameter we send to it. But it really doesn't matter. I wanted to show how simple it can be done. Right. So on OpenShift, on the Learn site, don't think that you just have to follow the guides. I showed you a couple examples that I can write other commands. And it's still working on showing me those commands. I don't know why it happened. Anyway, it doesn't matter. But write your own code, maybe deploy your own container and see what happens. It will do that. Now, if you're asking it to deploy something that needs, tens of gigs of memory and all that, then it will probably stop you and say that it doesn't have capacity. But it will deploy fairly complex stuff for you. Just remember that the moment you leave that interactive portal alone for 5 minutes, it kills all your stuff. So it's not really meant for something you set up and then next day you work on again. Like, that's not what this is meant to do. In that case, you need to install your own stuff. Oh, developers.redhat.com has a ton of training courses, and it actually has some of the similar ones that you have here, but it has additional content if you want to go into details with some of the more modern and advanced frameworks for developers that are out today that are very different from how we used to do things. We can, one of my favorite projects is called Quarkus, and what it allows you to do is to make a Java project that literally launches in milliseconds. So if anyone has run Java code before, you know that in the past when you've had particular big Java applications running, we could talk minutes before that application was up and running. from the time you ran it on the command line till everything was ready. We're down to milliseconds for that to happen now. And that is what Quarkus allows. Makes it extremely agile, and is a very interesting concept to actually learn about and see how it can use. It doesn't work for everything, but it works for a lot. Summary, we had a couple things we talked about. We talked about namespaces and projects. We talked about the API, the command line utilities. We talked about what a deployment or deployment configuration is. We talked about the routes, and the service, and we did a build, and it actually used a secret, but we didn't define one ourselves. And it actually also created a config map. We didn't care about that either. So that's the basic overview. I can absolutely go in and show a full cluster running, and I can show it from an admin perspective, where I have admin rights. Or we can ask questions or talk about something completely different, and I will just listen. So I will stop the sharing over here.
Hey Peter, can you hear me?
I can hear you now, yes.
So you mentioned that we should probably unlearn a lot of what we've learned in the past. And I hear that often a lot in the industry, especially as a person that's new to developing and new into the IT sector. And I just wanted to find out from you about your opinion on what we should actually, what's the guideline or the best method or approach we should take when wanting to set up a Kubernetes. Is there like a how-to or maybe some sort of guideline that we can start with, just from like step one?
Sure. I mean, I have the Red Hat answer for you, and that's cloud.redhat.com. It makes it very, very simple. And then there's the documentation of that also. I mean, the guided, or what I call the opinionated installer that does it all for you. You can literally set it all up in Amazon with answering a couple of questions, and those are simply your credentials, your key and your secret to log in, and then it wants to know where your Route 53 is for your DNS, or which one to use that you have. That's because it needs the DNS name to work, and it needs to manage it, so it has to be in Amazon. Other than that, it doesn't need any other information, and you're up and running. To run things on your own in pure Kubernetes, that's where it's a little more tricky, because Kubernetes is not just depending on the version, but where you're getting it from. If you're getting it from upstream, then you're getting what you're getting, and it's fairly simple to define what that is. But there's not a lot in pure Kubernetes. So what everyone is doing is adding their own stuff on top of it, like Openshift, right? It's opinionated in the sense of, hey, we need to have a console so you can actually easily interact with it. We need to have some control about how to do blue-green deployments and all kinds of other stuff that Openshift implemented way before that was available in Kubernetes. And other vendors are doing the same thing. So depending on which one you pick, your experience will differ a little bit. That said, you can absolutely deploy, if you go to the Okd.io site, there's a single command you need to run, and it will set up a cluster, small one, but it will set up a local cluster for you. And that will give you everything you need straight out of the community to get started. If you're new to containers, I will probably not start with Kubernetes. I will just start with Podman and Gang and just make some containers and get experience with how that works. And that was sort of what we covered last month. And the reason I say that is you need to sort of get challenged a bit and realize that when a container says it has a problem, it's not a matter of just logging on and looking at the log files anymore. There is that. But getting access to what it's actually doing and what happened, whether that's a problem with the code that is in there, or maybe just the way you're running container. I mean, did you give it the right privileges? Did you give it access to the right data? And how does it get access to that data? Did it get it with the right privileges and all that stuff? Those are things that you're going to run into as problems. And now once you have a basic idea, and I'm using the word basic as compared to a full container platform, then I will take that experience and move it into a container platform, and then you can actually start adding those additional layers of what happens when I have more than one running, what happens with storage when I have more than one running, how do I control my security? I mean, how do you, for instance, set up so if you have two projects that you can ensure that, let's say that in your environment you have a production system that is on version 2, and then you have a development system that is meant to maintain that 2, but you also have a version 3 development system for something, you know, for all the new features, and hence you have a test system at version 3. I can set up network rules in the production system of 2, for instance, to say I only want to talk to things that are for the from systems that are part of 2. And that's the only communication I'm going to allow in. So you're basically in control of your network coming into you. And I can do the same for my development thing, saying don't allow any traffic from production, right? So you don't want to have that on network. Typically, we would set up on a firewall. You may even have VLANs. And that's what you can set up within OpenShift as one of the advanced rules of saying, well, I now have a very complex set of settings, and I don't want things to go wrong, so I need to implement features to help me. And that's, again, typically you would go to your network group and say, hey, I need a firewall rule, or they will come and knock on your door and say, you can't have this running on the same network, or something else in that, and have the discussion. Now you can manage that on your own without knowing their firewall at all. All you tell OpenShift or Kubernetes, because this is a Kubernetes command, is to allow this namespace access to this service on my server, maybe on what conditions, but typically it's our namespace, or you can tie it down to a specific service or pod. So you can say only, for instance, the one that needs the pod that runs on top of the database should have access to the database service instead of all the other ones. So you can actually log it down the same way you could log everything else down that you dealt with. But you're adding this step by step. That's not where I will start. And then when something happens, you need to learn how to troubleshoot it. There's a concept called, I called it ephemeral all along, but there's an ephemeral pod. So one of the rules of creating a container is if it's not needed for runtime, it shouldn't be in the container. So if anyone gives you a container that has SSH in it, or that has, what else can go, like yum or apt or something else as part of its runtime, that's a problem. And it should be a signal that something can go wrong very quickly. The problem is that if you take a container today and look at it, and it is very restricted, then you may not have the commands you're used to in it anymore, right? So if you're used to debugging the network, and you're using the IP command to inspect the IP address, and if you take what Red Hat calls the universal base image, that only has the bare minimum needed to run an application, there's no IP command. So you may go in and go, well, how do I actually see what's going on? And in that case, you will set up, well, your basic command is called OCDebug. And it will actually attach a special container around it that has those commands in it, but they're not part of your runtime. And now you have access to actually inspect what's going on with some of the commands you're used to, but they won't be in your runtime. So it's a different way of looking at how the world works. That was a very long answer. I hope that helped. But
yeah, thank you. There was a lot of information there. I tried to keep track of it, writing it down. But thank you for that. And just to ask you one more thing. So, for instance, if I'm using a Linux server,
yes.
To run some sort of services, and I'm pulling it down from an apt install or something of that sort from a library, is that something that you would particularly keep in a Kubernetes environment, or should it stay within a Linux environment? A lot of the installers and repositories that are brought in from, let's say, again, from like apt installs.
Mm-hmm. So remember, first of all, a container is still Linux. That is, well, there are Windows containers now, but that's kind of very new and not necessarily fully defined yet. It's getting close. But generally, what's in a container, how you build them, is the same that you've known from Unix on Linux for a long, long time. And a very typical way of building them is to using your apt command or your yum commands to add, hey, this container needs to have my HTTP and Python or Ruby or whatever else that you need to add to it. That's as part of your build commands when you create your container. That's typically the first things that are in there, right? So you still need all those features. You still need everything on the core side is still maintained as those libraries. As those RPMs, those dep packages, and so on. It's just a matter of how do you distribute it, right? So you may actually now have the need to run an application where the developers were all running on Debian, and then you need to run another application where that group is running on SUSE Linux, for instance, right? And instead of having to deal with, wow, it's different package managers, it's different versions, you don't care anymore, because once it's built, you get a container image, and you're not seeing any of that anymore. So, but those two groups of developers would still need to create those packages, and there are still implementations where they don't use containers and they just install it from the package manager, like they've always done. But from a container world, you don't install from that. You install from the image registry, and however it was built, you don't care about. At least not. Well, you care about it if you need to send in parameters, right? How does it run? If I want to specify certain features, there's something called an inspect that can tell you what the container expects to see. But beyond that, you don't need to specify anything. So let me actually see if I can check this thing here. And anyone with other questions? There we go. So if there's interest, so this is actually a full cluster running currently on my system here. Let me actually check the oops. That's not the right window. It didn't share the right one. Yes, it did. Okay, sorry about that. Not sure. Okay, so there we go. That should actually show you the current cluster I have. So this is something I created last night. It's not that old, but as you can see, the options now are quite different. If you go to the developer view, you can actually see I've added a few more things in here that you didn't see before, like pipelines. When I hit add, you see a lot more in here. I don't want to say all projects. I want to say my demo too. There we go. So as you can see now, depending on the features that I add to my installation, this actually gets more and more complex. And the way that that is done, and I did not spend a lot of time on this, is called operators. So this is how simple it is to add features in OpenShift. You basically get a catalog here. And it is a filtered catalog at this point because it only shows the operators that are compatible with the version that I'm running. So I can go in here and I can say, well, let me look at databases, for instance. So these are the different types of databases that I can install as an easy consumable for my users, meaning for my developers. And as you can see, this is not just for let me say open source projects, for that matter, in the sense of here is something you can do from yum install. This is for hardware-based storage too. So they have these vendors that sell storage solutions that are used by big data centers, create an operator that makes it very, very simple for you to consume what it is they're doing. And as you can see, this list is long and it is ever increasing. So this is not a matter of just using Red Hat's OpenShift ideas of this is what Red Hat has developed and supports, but you can basically say, well, I may not mind what they did, but I want to use my own storage vendor that I already trust and have implemented. And you can probably find it in here already. And to install them, which one should we pick? I have to pick let's do a Couchbase. I go in here. Well, I don't want to do a purchase, but I can do an install. And what this basically does, it tells me that in order to run Couchbase, all I have to do is hit this install. That makes the Couchbase infrastructure available, and that includes all of these sub things that I can then configure and manage afterwards. And as you noticed, some of them come at an additional price. Some of them are not part of what OpenShift. I mean, basically, it's a separate vendor that this is what they live off, right? That's the way of making money. But that's all I have to do. So clicking install here puts it in. And if you look here, this is the big difference between the demo system that you saw and what I have here is, it's taking a little while because I haven't accessed it for a while. But as you can see, my list of operators here is pretty long and complex. And that's simply because part of what I do is I need to go through some of these things and demo these particular features. And I can have 2 hours on just, let's say, doing a compliance operator rundown, how that works. Or we can look at how pipelines work. Again, that's a complete meeting by itself. So there's a ton of sub-features in here that are very complex in their own universe. And even more complex than that, this is the Red Hat version of those. A lot of these exist from other vendors too, or other communities. Right? There are other communities that does fully open source for service mesh, for instance, not just the Kiali ones that we use at, or Istio, sorry, that we use at OpenShift. Again, there's a ton of stuff going on. Not sure a lot of this is worthwhile going through, but if you have questions specifically about the cluster or specific features, let me know and I can answer those. If not, I'm going to end the recording and hang around a little bit. Other than that, that's it for today. And I'm not speaking next Saturday, I can tell you that. I am speaking for the UK user group before next Saturday, our next Saturday meeting, but not for Novalog. So there will be someone else you're going to have to listen to that, not me. You're probably tired of hearing my voice after doing it 2 months in a row anyway. So thanks a lot for coming, and hopefully this was useful. Once I have the recording, I will definitely get it published. Thank you.